4-1 Congruent figures. What is congruent? Congruent means two figures that have the exact same size and same shape. There is a correspondence between their size and angles such that corresponding angles are congruent and corresponding sides are congruent. For example, the congruent statement, triangle ABC is congruent to triangle PQR, shows that the congruence and the correspondence of the following triangles. So here are the triangles right here. If these two triangles are congruent, that means corresponding angles and sides are congruent as well. So right here, you have angle A is congruent to angle P. Corresponding means is same position. So this is on the left side, this is on the left side. Angle B is congruent to angle Q. Those are corresponding angles, which is in the same spot. So corresponding means same spot. Those are congruent. And angle C and angle R is congruent. So you will see that this angle A, you have two curves like this. Those are congruent. That shows the congruence. One curve, three curves, three curves. Those are congruent. And then if you look at congruent sides, the AB is congruent to PQ. You see this one tick mark? That's congruent. BC is congruent to QR. You see two tick marks. That is an indicator for congruent. And then you see AC is congruent to PR, which is three tick marks. So if you see these markings, you can see which ones are corresponding, which ones are congruent. So these are indicator. These tick marks and these angle curves, those are indicator of congruent angles and size. Why could the congruent statement also be written? So you have angle BCA is congruent to angle, triangle BCA is also congruent to triangle QRP. This is, instead of writing ABC PQR, you can write this way as long as B is congruent to Q and they appear first, so these are congruent. C is congruent to R, and then A is congruent to P. So if the first letter, they're congruent, second letter congruent, third letter congruent. As long as if they are matching, like matchy, like congruent, then you can write it this way also. So this, if you write this or if you write that, either way is correct. Because if you look at this, A and P are congruent. So they appear first, right? They're corresponding right here. B and Q are corresponding. C and R are corresponding. So the way you write A, B, C, and P, Q, R, the first, second, third, they need to be corresponding, okay, and congruent. So you can write this way and this way, but as long as the order of the letters are corresponding and they are matching, okay? So make sure that happens. So we're identifying congruent corresponding parts of the congruent figures. So take a look at this. These two triangles are congruent, and you can write the DEF. So you have DEF. Triangle DEF is congruent to RST. Now, why did I write that way? Look at D. D has two curves. R has two curves. So they need to be corresponding. So you need to write D and R, okay? They are corresponding. Matchy, okay? And then E and then S, they have only one angle mark, right? Matchy. And then F, you have three marks. T, you have three marks. They are matchy. So you gotta do matchy. They have to be corresponding. So you cannot write DEF and then write RTS. You need to make sure D, the first letter, matches the first one, second one, third one. They need to be corresponding. So there are other ways of writing this. So you can write EFD. So E matches STR, because E and S, they are matchy. F and T, they're matchy-matchy. When I say matchy-matchy, I'm talking about corresponding, okay? And then D matches R because of the marking. This one has 3, 3, 2, 2, 1, 1 angle marks. And you can also write FDE is congruent to TRS. So F matches T right there. D matches R. And then E matches S. Matchy matchy. So if you write this, any of these, as long as they're matchy matchy, they're written correctly. So let's practice. Identify all pairs of congruent corresponding parts. So triangle ABC is congruent to triangle RQP. So you can draw this, and then you can write the congruent angles and sides. You can also do matchy-matchy. So angle A will match angle R. So you can write angle A is congruent to angle R. These two are corresponding. B should congruent to Q. C should be congruent to P. So this is P. So can you write this, please? And then the sides, I want you to, the best way is to draw. So AB is congruent to RQ. BC is congruent to QP. CA is congruent to PR. So just go same direction, but just draw and just write ABC, RQP, and you can actually visualize the sides. So when you do sides, I want you to draw this line above, and this is the congruent sign. So please copy these two. So we're gonna practice more. You have quadrilateral. NPLM is congruent to EFGH right here. We're gonna find the value of X and the Y. So we're gonna use algebra. So what you're going to do is N and E is corresponding. Then that means they are same, congruent. So you see this N and E, they are matchy-matchy, and they're 72 and 7y plus 9. So you can set up an equation that 72 equals 7y plus 9. And subtract 9 divided by 7, you are able to solve for y, which is 9. The side LM is corresponding to side GH, therefore they are congruent. If you look at the shape, this is the shorter side of this is the longer side, this is the longer side, this is a shorter side, so this is kind of turned. Also, you can see that LM, GH, they are corresponding. So LM, GH. So these two are congruent, equal to each other. So you can set up an equation like this. 8 equals 2x minus 3. Add 3 on both sides, make that 11. Divided by 2, 11 over 2. So that is the x. So you can use congruent equal sign for corresponding sides and angle and solve for x and y. Third angles theorem. So this is the theorem that we need to know. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. This is called third angles theorem. Let's memorize this. So I'm going to show you with picture. If angle A and angle D, if they are congruent, you see the two marks, these two are congruent. In angle B and angle E, if they are congruent, that means angle C and F are also congruent. That's why this is the third angle. First angle, second angles are congruent, and the third angles are also congruent. This is called third angles theorem. It only works when first two angles are congruent to each other. So we're going to do practice with that theorem. Find the value of x. Take a look at this. This is 55. This is 65. Then this right here will be 55. Then what would this be? 65, right? You see that there's a one curve. These two are corresponding. Two curves, these two are corresponding. That means this T is corresponding to this one based on the third angle theorem, third angles theorem. If the first two are congruent, then the third is congruent. So you can, I want you to write 2x plus 30 here. And then what you can do to solve for x, a triangle has 180 inside. That is the sum of the interior angles of a triangle. So you're going to do 55 plus 65 plus 2x plus 30 equals 180. So you're going to add these two, which is 120. Add 2x plus 30 to that and make that equal 180. So what you're going to do is subtract 120, which is from 180, 60, subtract 30, which is 30 divided by 2, and you're able to solve for x. So x is 15. Are the triangles congruent? Decide whether the triangles are congruent. Justify your reasoning. We are given a pair of congruent angles and 3 pairs of congruent sides. We also have information from the vertical angles theorem. So let's take a look. You need to have clear indication and justification to prove the two triangles are congruent. You need to have clear indication. So first of all, you can see that the one tick mark, these two are congruent, the sides. The tick marks are for the sides. Two tick marks, these two sides are congruent. Three tick marks, those are congruent. Those are all corresponding to each other. You also need to have 3 sides congruent. So in order for these to be congruent, you need to have 3 sides, they are congruent to each other. And also you need 3 pairs of angles. They all have to be congruent. So if this is 92, that's 92. These are corresponding, they're congruent. This is needs to be congruent to this one. They are corresponding, so they need to be congruent. And then this angle, they need to be congruent. These are vertical angles. So vertical angles are congruent. 92 is congruent. Then the third angles theorem, these two angles are congruent. So in order for two triangles to be congruent, you need all 3 corresponding angles need to be congruent, same. All 3 corresponding sides, they need to be the same. They need to be congruent. So with this information, if this is 92, this is 92, right? That's congruent, angle 1. Angle 2 is congruent based on vertical angles theorem because vertical angles are congruent. Then based on the third angles theorem that we have over here, if 2 angles are congruent, then the third angles are congruent, then we can conclude that these two, angle R, angle M, they are congruent. So now we can use these to prove that all 3 congruent angles, corresponding angles, and all 3 corresponding sides are congruent. The sides are congruent because you have the tick marks. They gave you the tick marks. If you do not have the tick marks, then it's not congruent, okay? You have to have the tick marks, matching tick marks, these lines, okay? So we can actually use the third angles theorem to justify these 2 triangles are congruent. So you have to write then we can use the third angles theorem, okay? So we're going to prove 2 triangles are congruent. We're going to use different theorems to do that. So let's start with the given. Let's write this down. The given is MN is congruent to QP. So let's look here. MN is congruent to QP. Okay, so this one is congruent to this one. So this is a tick mark, okay? And then MN is actually parallel to PQ. The marks for parallel is these arrows. When you see these arrows, they mean parallel, okay? So when you're doing this, you need to look at these markings, okay? Tick mark, arrows, okay? And then O is the midpoint of MQ and NP, okay? That is given to you. So let's write that down. We're going to just write this given first, and I'm going to explain why. we're going to write this given later on number 4, okay? So we're going to write this first, okay? We're going to write MN is congruent to QP, MN is parallel to PQ, and then write given. And then what we're going to do is we have to use angles to prove, angles and sides to prove that these two, we have to know what we're proving. This triangle is congruent to this. In order to prove, you need to have all three sides, all three corresponding sides, and all three corresponding angles. They need to be congruent, all three, sides and angles. So what you're going to do is write, because these two sides are parallel to each other, we can write the reason P, Q, O, which is this angle. So the middle letter is the angle, okay? Q is congruent to N, M, O, this angle. So basically this M and this Q, they are alternate interior angles because these two lines are parallel. They gave it to you. So you can conclude that this has, I want you to do a mark here and do a mark here. These two are congruent, okay? So I want you to write alternate interior here. That means this angle, M, N, this one, and this one is also congruent because you have transversal here. So you can write OPQ is congruent to ONM, okay? So now we have this angle, this angle, this angle, this angle. So we're proving these two triangles to be congruent. So we have angle 1, angle 2, angle 3 is congruent. You can use vertical angles or you can write third angles theorem. You can conclude that because angle 1, angle 2 are congruent, then angle 3 are congruent. Third angles theorem. So write angle POQ is congruent to angle NOM. The O and O right here. Okay? So the middle letters are your angles, okay? Now, we got all three angles congruent, so we're good to go. Now we need to do sides. So now we're going to use this sentence from the given on number 4. Write this down. O is midpoint of NQ and NP. And then we're going to add 5. I'm going to add 5 and 6 here. So you can write 5. MO is congruent to QO. PO is congruent to NO because of definition of midpoint. So this is right given for number 4. Please write this 5 and write this 6. So 5, I'm going to show you. So because this side is already congruent, they gave it to you, we need to prove that this side right here, MO, is congruent to this side. Because the midpoint, right? O is the midpoint of MQ. The midpoint cuts something in equal, 2 parts, in half, exactly half. So because of the definition of midpoint, I want you to write that. This side and this side of the triangle is congruent. Same thing for the other side. The O is a midpoint of NP. So this side right here, NO, and then OP, they are also congruent. So I want you to do these tick marks. You already have a tick mark for this side. Do 2 tick marks here, and then 3 tick marks here. Therefore, this triangle right here, MNO on the top, and then this triangle right here, QPO, these two are congruent. That's what we're trying to prove, right? So now you have all 3 angles and all 3 sides, then you can prove 2 triangles are congruent. So let me repeat. In order to prove 2 triangles are congruent, you need 3 sides, 3 angles, all to be congruent. Otherwise, you cannot prove it. You need all 3 sides and all 3 angles. The corresponding, they need to be congruent, okay? Otherwise, you cannot prove it. And in order to prove it, you can use third angles theorem, you can use vertical angles, you can use alternate interior if they tell you if these are parallel. You can use definition of midpoint. You can use those theorems, converses that we learned to prove 2 triangles are congruent, okay? So properties of congruent triangles theorem. Reflexive property of congruent triangles. Every triangle is congruent to itself. Symmetric property of congruent triangles. If triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. Transitive property of congruent triangles. If congruent ABC is congruent to DEF and congruent DEF is congruent to JKL, then congruent ABC is congruent to JKL. So we know these properties. Reflexive means repeat. So every triangle is congruent to itself. Duh, right? Symmetric means switch. So ABC, DEF, DEF, ABC. If you switch them, they're congruent to each other. Transitive, if this triangle is congruent to this, if this triangle is congruent to that, and then the first one and the last one will be congruent to each other. So we know transitive like that, right? So we can apply reflexive, symmetric, transitive properties to congruent triangles. This is called properties of congruent triangles theorem. So we're going to wrap this up. If a triangle GHJ is congruent to triangle M and P, what corresponding sides and angles are congruent? So we can write the angles A, angle G, and angle M, they are congruent to each other. Angle H, angle N is congruent to each other. Angle J and angle P, they are congruent to each other. What about the sides? GH, MN, corresponding, they are congruent. HJ and P, they are congruent. JG, PM, they're congruent. The best way to do this part is to actually draw the triangles, okay? So I want you to draw the triangles and then write the corresponding angles and sides when you do this, okay? So I attached this worksheet. What I want you to do is, listen carefully, I want you to do number 1, and I want you to do number 2, ABC, number 3, ABC, number 4, ABC, okay? And then on the back, you have this play on words. This is extra credit. So I'm going to give you extra credit for this if you have time to do it. So let me repeat. You're going to do the worksheet now. You're going to do, well, number 1, everything A, B, C, D, E. Number 2, just do A, B, C, skip D. Number 3, just do A, B, C, skip D, E, F. Number 4, you're going to do A, B, C, skip D, E, F. Okay? And then the last page, this one is extra credit.